Okay, so as you can see, I am making a 4-bit full adder. So yeah, but in this case, I'm modifying it so that it will show me the tens place and then the ones place. So let's actually try that, shall we? Give me a second. Alright, cool. Let's check out my stuff. All that works. Alright, good. Alright. So, what do we have to do next? Let me just turn this off for now. Alright, so next on the list for me was I needed to get this inside of my circuit. So let's see, we had indicated so I want B and A naught or C naught or A B naught. In this case, my ABC, A will be my MSB, so it will be here. Or rather, here. These three XORs. So this is my C and this is my B. So I will need an inverter for, let's put it there. Alright, let's try it. Alright, so let's see. What do we want to do? We want to AND a few things, or a few things, and just be cool. First things first. Let's get 3 of these in place for where each of these will be the inverted value of the outputs of the XORs, of the adders, the sums. So now we have that. Then we want B. Therefore, we want B, A naught, or C naught. So that will be my first case. So let's put that there. Let's put that there. Let's say we want C or A naught and B. Okay. Let's get another OR and let's put that together. And then we also want A or B naught. A and B naught, rather. So A and B naught. So this, in effect, en effet, is my, did I say and carry? I'm going to assume I also wanted to put carry. So what I'm going to do, just to make sure, is I'm going to replace this with components in CMOS, search up 4075, 5 volt, and then I want carry. Oh. Carry here. Okay. Give me 1 second. All right. So let's continue. Let's put this all to high. Why is it set that way? Okay. All right. So let's try it out. Let's see what we get. Oh, I made a mistake. All right. Play. What do we get? 0, 0. Oopsie daisies. Okay, let's try it now. 1, 1 equals 2, 8. Nothing on 8. Okay, let's see what our problem is now. We're doing 8 plus 0. So let's actually do that. Let's calculate that. Should give me just 8. That should be fine. Oh, what are these? Hold on. Whoa, what the fuck? Why are all the switches working together? Oh god. Multisim sometimes, I don't know. You annoying son of a gun. Okay, alright, calm down. I'm sorry. Alright. Alright, 0, 0, 1, 1. Okay, why am I getting nothing on 8? Five there. Is there a carry? No. Therefore, do not add. But what am I getting at the output here? One. I'm telling it to add 6 here. Shit, something's going on. This doesn't work. Is it the carry? No. What the? What the fuck could it possibly be? Did I do my theorem wrong? Let's try it out. Let's see. I said A naught B or B C naught or A B naught. Factor the B's. A naught. Seems fine to me. Because we had determined previously that any number, and carry. Do I want it to only work if and only if there's a carry? So let's try that actually. Replace component with back to TTL with a 7432. Let's make this the inversion of C, inversion of B, inversion of A. I said I want A naught, C naught. And B or B naught A. That, all of that, either or with the carry to add 6. Question is, why do all the switches revert back to that weird position? Oh, when I clicked on numpad. Oh, I see. I'll just place it to whatever number. Okay. Let's try it now. 0, 0. 1, 2, 2, 4, 8, 16. Too much, too much. 18, 19, 20. Alright. Okay. Alright. So let's try it out. Now what we want is it to add 6 once more if it sees the number after adding 6 again to be let's say I want 15. What is this? Oh, oops. Yeah. $15 does not work. Why is that? 12 works fine. But if I put anything above 12, it thinks $13. At 14, it decides to add 6 again. So $13 is fine. At 14, 17 is okay. Seems. So 12. Let's add another 8. That one's fine. Remove 2 8s to 16. 18 works. 19 is fine. 17, yes. Do my 4s not work? My 4, that's a 2. 16. Where's 12? Let's add 2. Nothing. 15, 16. So 15 and 14. For some strange reason, 16. 14. Okay, let's see what exactly is going on. So if I add say I were to, like I said, oh shit. If only you could disable this. It's just too much effort to program that in. Fortunately, the switches are separate, so I need to do this manually. Okay. Alright. So let's just quickly look back again as to what's going on. $14 and $15. 16 is fine. So 14. What do we know from 14? We know that if we look at what we're adding 1, 0, 1. This is 14 alone. Wait. 14, 1, 0. Plus nothing. This will give me that. Therefore, add 6. There you go. I have 4. And that conflicts with this one. No. It doesn't conflict. It with the carry after. Does this matter about the carry before? Okay. I think what I need to do is eliminate, is get the carry from here. There it is. 14, 15, 8, 16 does not work. Why is that? If I say 8 plus 8. Nothing. It just brings a carry. And what did I say? Carry on the first. But why is this? A lot of them conflict with each other, it seems. What do I see? Each of them do not have a carry except the ones after. Fuck. Oops. Wrong monitor. Okay. Why does it do this? conflicts with the other one, and I'm not sure why. Move all of this so I can get 2 papers. Position myself a little bit better. So here is basically every case from 20 to 29. This is 30. So with all of this, I'm gonna do cases where my number is less than 10 and see if it's the same. So 0, 0, that's fine. I mean, we could just try it out and see. One works fine. 2s work fine. 4s work fine. 8s work fine individually. 9, 11, 13, 14. Should be 12. 18 is too high. I don't know why. 16 is too high. 12. 16 doesn't show. 14 does. 15 does. 16 does not. Add 4. That's 15. 14 does not show. It does show. 15 does. 17 does not. 17, 18, 19 does not. So it seems 8, 16 doesn't. 17, 18, 19, 20. So it's every number going from, so it's every number from 16 to 19. So that would be, let's just do something simple as this. 1, this is 0, this is 0, this is 0, this is 0, this is carry. But because there's a carry, I have to add 1, and then it makes it into 16. Now, okay, let's do the other one. This is 0, oh, this is 1, this is 0, this is 0, this is 0, this is a carry. 0, 1, 1, 0. This should be 0, 1, 1, 1. 17. So my problem I'm having, it seems that when it checks for this carry, it seems to me that I have told, because if we switch out this carry, let's eliminate this LED. We don't need this. Let's change it to green so we could see it better. Okay, so if we do this way, where we have the carry after, some numbers don't work. (16, 17, 18, 19 is fine. 20 doesn't. Two, 4, 8, 16, 18. (16) 20 does not. 20 doesn't even show the correct thing. 20, if I say I want to add 20, which I have, where do I have 20? I have it here. Let's add 20 and watch. So basically I should be getting a 4 here. Nothing, nothing. Nothing, right? It's a 4 and a carry. Correct? Which then tells it that, okay, it's greater than 9. So make it into the tens place. Therefore add 6. So it takes in my 4, which I have here, and adds 6 to it. So now I'm at, I should be at 1, 0, 1, 0. So there should be a 1 here, a 1 here, 0 there. Wait, hold on. Should be a 1 here, correct? Then a 0, then a 1, then a 0, right? Camp's too small, whatever. So now what this tells me is if my value this tells me now that that my value here should be at 10. Therefore 10 is too big and you cannot display it. Therefore add 6 again, meaning there should be an output here, but there isn't. Why? Because there's no carry, and I have said that with this logic it should output a carry. Now it seems to me there is one here, but the carry is ineffective. So let me eliminate this carry entirely and bypass this gate and see what I get as my result. Zero. As intended. And let's check, is there voltage at the last carry? There is. Okay. Then that means let's go through it all again. 1, 2. No, okay. 4. 4 doesn't exist. 5 doesn't. 6 doesn't. 4, 8, 9, 10. Yeah. Curious, is it every number before? 8, 6. 6 does not. 12 does. 14 does not. 13 does. 13 exists. 14 does not. 15 does not. 16 does not. 17, no. 18, no. 16, let's add 3 to get 19. No, but 20 does. So every number after 14 and every single number. So by just saying only if it sees that, it sees the first number. So if we say I want to add 6 only if I see the first string of numbers, then it's going to skew it. So what I need is for it to only add a 6 if it sees specifically a carry when there's 0, 1, 0, 0, which if you look at each individual one, there is a carry. But if we go back here, we were testing every number after 15 because that would seem to not work. So this is 18. That makes sense. Now, question is, does this exist anywhere else? No. So, if I do the next one, 19, then it doesn't. Therefore, this, or it won't exist, because if we do it one more time, using 19, we get 1, 1, 0, 0 with a carry, which is ultimately not a carry with a 4. So we need to determine every number from 4 to 13, and if there's a carry from 4 to 13. And this first carry is when it checks. So, but the problem we're having is when we do that, if we were to reset and add a carry from the beginning, and then another problem occurs. Let's see if we can recreate that. $16 doesn't show up anymore. 9, 10, 11, 12, 13, 14, 15, 16 doesn't show. $16 doesn't show, 17 doesn't, 18 doesn't, 19 doesn't, 20 does. So apparently we're getting some conflict between these numbers and these numbers. So let's say 16. 16, if we add 8 plus 8, is a carry plus a 0. Therefore, because of the carry, you must add 6. Therefore, your value becomes 6. Now, the problem is with this is that this also occurs over here when we add 15 and 7. It's the same thing. There's a carry, and it tells it if it's a 6. So what it seems that we have to do is maybe change it a little bit so that it only so that if there's a carry at the beginning, and it indicates it's greater than 10, but we also want to know if our number specifically is this. If it shows from 10, 11, 12, 13, 14, 15, 0, 1, 2, 3. So we want to add 6 to the next number if and only if, in this case we're going to switch it up so that we'll look at this number. Seriously? Looking at these numbers instead. So we want 10 to 15 with this carry, or 0 with the new carry after it adds this. So basically we check. First it checks, alright, is there a carry and did it add 6? I guess it's already predetermined, so we can just say put it with the carry, but only if the value is from 0 to 3 with the second carry. So it's carry and 0 or 1 or 2 or 3. This will determine if the number is at this stage where after adding 6 from to here, it doesn't skew it. But over here, we need to say, all right, so from every number from 10 to 15 with a carry. So let's look that up online. That was my YouTube channel. Let's go on 32 by 8. Let's go on 4 variables. And let's say we want every number from 10 all the way to 15. So this is A or C, A or B. Okay. So let's write that down. So we know that it's A and AC or AB. This, once again, this can be factored again to A or C or B. And this is just going to be for all numbers from 20 to 25. Now, if it's 26 to 29, instead what we need is A, C, B. These are going to be my basically my sums, but we're going to need, let's say, X. Let's get right here. So for numbers from 20 to 25, I will need carry 1 and A and C or B. These are my sums. So this is from 20 to 25. Now if it's from 26 to 29, as we can see here, that makes it to 26. What is this? This is 15 and this is a 11, 26. So from every number from 26 to 29, we need to have carry 2 and every number from 0 to 3. So let's go back here and do that where 0, 1, 2, and 3. We determine that's A naught, B naught. So it is carry 2 and A naught, B naught. So this, in effect, will give us the value we need. So if we review it, and if these are the sums, we want it to add 6 after everything if and only if the number after adding 6 the first time is either 10, from 10 to 15. This is implying it's 20 to 25. If it's from one of these numbers with a carry, which is indicated here, so and carry, so we determine that it is A, so this is MSB, second to last, and LSB. If A and C or B with the carry, this will tell it to add 6 because it wants to display 20 to 25. Now, if it's 26 to 29, we say only if there's a carry on number 2. So, and these are ORed. So it's either or state. This cannot exist beforehand because the C2 will never be on, so this won't work. If this is happening, C2 won't happen. C2 will only happen in this case and these cases, excluding this one, of course. The adding 2 15s. A0 and B0 will be only when 0 to 3. So basically it's implying that 0 0 0 0 0 0 0 1 0 0 1 0. What do these have in common? Well, the first two are the same, and the last are different. So basically, only when the first two are low, because every number after that, there's either a 1 on B and 1 on the A. This would be A, this would be C, C, and D. So it's only when these two are low. So what we need is an AND gate here, an AND gate here, and an OR gate here, an AND gate here, an AND gate here, and another OR gate with 2 inverters. So let's do that. Let's try that out. Let's eliminate this. Oh, clicking numlock. All right. So let's see. All right, 1 second. Cute doggo. We want to invert 2, only 2. So let's take these two and put them here. I want to invert A or B. So only if my output here is A or B. So this is B, and this one is A. Delete this and delete this. Okay. So we indicated that we want an output. Let's do the first one. If carry 2 exists, if A is high and either B or C. So this is B. And up here is C. Then we also said I want it to also go high if there's the new carry and when both the first two values are low. Either or. So this, in theory, should add 6 once more. Let's try it out. 16. Okay. Well, it's a good start. 8. Good start. Okay. 1, 2, 4. That's a 6. Yeah. Is that 8? Shouldn't be 16. Just give me 12. I just got 18 from that. 16. 17. 19. 18. Okay. Let's keep going. 18. If I add if I do 12, this is 12. Ten equals 16. Ten equals 16. 11 equals 17. It shows 19 twice. Okay, so what exactly are my problems? 16. It shows 16 twice. Okay. So what numbers am I adding? I'm adding 12. Not even 10. 10 10 in binary. If I say I want to make 10, I get carry. I'm adding 8 and 2. Therefore, I get 0, 1, 0, 1, which is 10, which is greater than 6, which it freaks out the first time. Then 0, 0, 0, 0, carry. Nothing. This is a problem. As you can see, I guess the carry exists. Is this the second? This is the first carry or second? This is the second carry. This shouldn't be. I'm getting no carry at the beginning, but my value is greater. So add 6. I mean, is it working as planned? Five volts, 5 volts, 0 volts, 5 volts, with no carry, but it's still high. Therefore, add 6. Is it not adding 6? Why am I not adding 6? It's adding nothing. Excuse me. It makes it 16 because it's adding 6 regardless. Question is, why isn't it adding 6 again? It should be adding 6. Here. Zero, zero. It's why isn't it adding 6? I don't understand. Why is it not? Why is it not? This is 12, and this is 10, and it's adding 6. Add 6 here. Add 6. Therefore, is this my MSB? No. Why? Is this high? Should it be high? What am I adding? My value is 10. Which is exactly what I'm putting. If my number is greater than, if my number is 10, carry, therefore add 6. But why? The question I want to know is why it's not adding 6. Why does it not add 6? These two conflict. Because the thing is that I want to understand, so let's say we were to open the original one. Let's pause this and play this one. There. Now let's check. We have a voltage here. We have a voltage there. We have a voltage there. That means this is high, therefore this is low. Adding 6 to my number. Oh, it just adds the 6 anyway. Okay. Okay. Alright. I'm looking at the wrong thing again. I should be looking at the outputs. The output, when you add 6 to the 10, if I say add 10, I should get nothing. We have 10, then add 6, therefore 0. Output should be at nothing. So if we were to check the output of each one, assuming it's on, we get 0 volts, 0 volts, 0 volts, 0 volts. So we have nothing. But it carries. It carries 1. After the fact, if we add things that I want to try to understand is basically it happens twice, that current state. So maybe what I could do is say do this instead, where this state here can only turn on, but wait, this state can only turn on if C2, A0, B0, and C1. So let's add another. So we say only when both carries, because in that case, then it won't. Then it should be fine. 10, 11, 11. That's 18. That's 19. So let's go through it all again. 1, 2, 4, 3, 4, 6, 5, 9, 7, 8, 10, 12, 11, 13, 14, 16, 15, 17, 18, 16, 19, 20, 22, 26, 30. Okay. So we've seemed to get it to work as intended. Hey Cat, if you want, you can type in chat. Tell me if that works. Just write something. Be useful. Alright. So this seems to work as intended. Oh. Okay. Well, okay. Only with YouTube channels. Huh. Okay, I see. We'll see how long it takes to make a YouTube channel then. Or maybe look up, I don't know. Because I see where you're getting at. Okay. So now, I need to indicate, I need to differ between this one and this one. So I need to tell this encoder here I need to, so right now what it will do is that it will display a 1 for the tens, but I want it to also display a 2 and indicating that it's like a 20 or something. So I need to differ. I need to be able for the decoder to differ between both. So I know that if I'm adding 6 here, therefore my number is 20. So let's actually try that. Let's say I want to add 14. Oh, yeah. Fuck. 15, and I want to add 19, 0. Therefore, that's 20. The lowest possible number has a high there, therefore I need to be able to differ between both. Okay, cat, do you understand logic? I hope so. One thing I am curious to note is if I do this. Okay. Alright, now we know for sure. I want to differ between both. How do I differ? How do I differ between every number I guess I could say if this is high, I probably would I need an XNOR, an XOR, and I need, if both of them are high, could it be possible that, no, it has to add 6 twice, so it has to be high at all times. So if both of them are high, let's try this. But it'll do it if both of them are low, which doesn't work. So let's look up. Is this the NAND gate? Will it help us? If both are high, go to low. If either or, go high. This, I don't want this state. All I want is this in the middle. if it's either or. But this case, let's assume we want one. Let's say if we go back to our circuit here, this to be carry A and this will be carry B. Basically, we want, if this is A and this is B, we want, if B were high, so if the carry after it adds 6 again, this alone can't exist, therefore only this can exist. But if both of them are high, which can happen, it will turn off. And instead, this is what we can do. So we take an XOR. Let's delete our carries. Place this here. Oh, wrong one. Just try to make it neat. All right. So then we'll take an inverter. Ooh. And we'll say if both of these are high, which only exists in one possible case, if both are low, wait, hold on. If both are low and output 1, no, wait. There's another problem that arises. I'm trying to think. Don't worry about it. What do I do? What do I do? I want it to differ between both, but I do not want it to work if it's low. So I think one crude way of doing it would be that if it's low, we'll do this. So what this does here is, if this is a low, it goes through an inverter and turns it on high. If the EL is on, which is lamp enable, if it's set to high, it will it default it to 0? Let's see it. No, it just turns it off. So let's put this. Oh, wait. Let's try this. If we take here, which these are permanently high, if we attach it to the carry, all right, it gives me an error. Probably because it's shorting it straight to ground. So what I'm gonna have to do is put a resistor so that it doesn't freak out. Say a 1K resistor right there. Okay, it defaults it to 8 if both of them are high. So let's see. Let's keep going until we find the one that Oh. Going on the other screen again. Let's disconnect it here. Let's do it like this. Let's try LT. Defaults there. So let's delete this. Delete that node and say LT goes directly high while the BI goes through a resistor first so that I could short it to ground. Will this give me a 0? No, it turns it off. Okay, so that method does not work, unfortunately. It doesn't at all. That method doesn't work. Put it to 2 only if it's... There's no asynchronous inputs because this is not flip-flop, so you can't do it that way. I want it to... It's either or. Let's go back to what a NAND gate is. Wait, a NAND gate? Oh wait, hold on. I was messing around, wasn't I? If both are low, output a high. If both are high, output a low. But it has a high in every case. Now, what about a NOR? Ultimately, I had forgotten what... If both are low, output a high. If both are high, output a low. So ultimately, what I could do is if I invert the inputs, I can say that if both of them are low, either or, if both are low at the inputs of it, then it'll go high. But if I say, if they're both high at the inputs, so implying that they're both low, it outputs a low. So what I could do with a NOR gate, which I do not know what the hell that is, a 74LS2 02. Is that what it said? Let's replace 7402. Aha. Okay. Invert that. Now let's take 2 inverters. Place them here. So that basically what we've done with this is that we've taken the truth table, as we see here, and said that if both are low, by both are low, either both are high because we're inverting it, output a high. Therefore, we can put this directly here. And then we can say if the output is a low, which is in every other case, output a high at A. But that means that there's a I'll show 1. But if, let's say, we say that's 16, right? See, 20, 21, 22. So that's the problem I'm having right now. $28. It messes up at 28. Huh. All right, let's diagnose it. Let's diagnose this further. Short 2 to ground. And put this over here so it's normal again. $16, $20, $24, $26, $28, $29, $30. How does uh 18, 16, 20, 24, 20, 26, 26. At 26, what is 26? 26 is 11 plus 10. What do we get? Well, we get, so if we take a look at what 26 is, which is here, it indicates that if it gives us a carry and a 10, we add 6. Then it's 0 and a carry. Therefore, we have to add 6 once more. So our output will be 6. But what happens here, it becomes 16. Therefore, what's happening, our output, as we can see, is 16. So the numbers area is still working. So if we'll add 1, 17, 19, 18, add 2, 19. See, that's fine. So what's happening is, it seems to me that when we do this operation out of these, it ignores this, and it just actually just ends up putting this. What the fuck? Uh, 16, yeah. So let's take our voltage and check. Is there an output here? Yes. Output here? Yes. Therefore, output double high, meaning double low. There is no carry. That's wrong. There should be a carry. Oh, oops. The fuck? That's not connected well. That's not connected to the right place at all. There you go. Okay. Well, that fixes that issue. So I was just being a dumb blum. Okay. So now we need to fix two other things. How to eliminate this from showing a 10 regardless of the first number. So what we can say, what we can try to do is every number, so let's say I want every number from 0 to 9. So 0, in fact, we don't even need to do it this way. We just go online to our K-map generator and say from every number from 0 to 9, we want something. B naught, A naught, or B naught, C naught. So A naught or B naught, C naught, which if you see from here as we were continuing on the way to 9, this would be common between them. We take this, and if there's a high, we short the first one to ground. If it's everything above 9, that's everything above 9. If our number is greater than 9, so basically what I'm trying to do is if my number is either less than or equal to 9, then output a low we could ignore the first one right here. This will be C, this will be B, and this will be A. So that if the number after adding them together is seen as anything that's either greater than or equal to 9, then using this Boolean algebra here with the right logic gates, we're able to stop it from showing a high when we want to. So we want it to stop showing a high when it's either greater than or it's less than or equal to 9. Wow. In any case, so let's first get ourselves an OR gate and an AND gate. We said this was A. So it's A or A naught or B naught C naught. And then we take another inverter and then this means we slam this low. Huh. Oh, wrong one. Connected here. Low. Therefore, if my number is greater, turn to 1. Why is it still stuck at 1? Low. Huh. That's interesting. Okay. Okay, that doesn't seem to work. In that case, we need a decoder. So we need to take by saying it right. Right. We need a decoder. So that if certain state, then this. So 2 to we need a decoder. So how does a decoder work? Intriguing. Is this the same one? Yes. So as we can see, a decoder, 2 to 4 line single bit decoder implies, as we can see, if we have 2 different inputs, or in this case we'll have 3. It would be 3 to 8 because of 3 different bits. So if we do just a decoder, and then we say, all right, so if A0 will be our carry for the when we add 6 once, and A1 will be we add 6 for the second time, we're able to basically decode it between 4 different states. So if we take our truth table here, we'll say that if both of them are low, therefore D0 goes high. But in this case, D0 will leave alone. If A0, so if there's a carry, we'll say D1 goes high. Therefore, we'll just put this into the 1. And then if there's a carry here, this state can't exist. Therefore, we will only use D1 and only D3. If D3 exists, then that means it will go high. We will put this into the 2 slot. So basically, if I were to draw it, so if we have the decoder, so let's say we have carry 1, carry 2, and we have so we have this going through an inverter, this also going through an inverter. Back at this. And we'll draw another AND gate, another one, and another one. And it will say if this is inverted, but it's not, if this is inverted, and this is not, and if none of them are inverted. So this really bad sketch basically implies if both of them are inverted, so if this is C1 not and C2 not, this is if this is C1 not C2, this is C1 C2 not, and C1 C2. So basically we'll be able to decode between each one depending on what our inputs are. So let's try that. Let's get a decoder into our circuit. So first, clean up the garbage. Now we have and let's create that decoder. Both of these are low. If the first one is low, we want this to be 1, that to be 2, that to be 3, that to be 4. So this truth table I've created here indicates what my outputs will be. So we'll just call this A, B, C, D. Or I guess we could number it. So 1, 2, 3, 4. So 1, 2, 3, 4. So if both carries are low, it will output something on 1. If carry 1, which is basically add 6 ones, is high, then 2 will go high. Therefore, and then also this one must also be put into place. But what we're able to do here, can we eliminate? Because we're only using 2 possible states, we can potentially only use 2, but we might be able to use this with 3 when we get up to 30. So, wait 1 second. Sorry about that. Let's continue. Alright, so let's create this decoder into our circuit. So, like we said, if C1 is high, we want 2 to go high. Therefore, C2 must be low and C1 must be high. Therefore, C2 must be connected to C2's low and C1's high. So, what I've drawn is wrong, but it's fine. Delete this, and we'll just do this. C2's low. It's connected here. And this there. Let's then say, so when C2 is low and C1 is high, output here. This is when C2 is high and C1 is low, and this is when both of them are high. So we said if C2 basically if C2 is low and C1 is high, meaning only when you add 6 once, output of 2. If both of them are high, 1 because you're adding 6 twice, output of through 4. So we take this and we put this on 1, and we take 4 and we output this on 2. Oh my god, my dog. I'll be right back. Sorry about that. Once more, my dog is annoying. Alright, let's try it with this circuit. With the decoder we've created. 0, 0 everywhere. Let's say add 16, correct? 20, 22, 26, 7, 28. Nice. Okay, so now we just need to do one more thing, which is to get 30 to work. So basically, what we're going to be able to do here is actually implement one of the decoder's states. So that, because if we look back, all the way back to this state here, when you're adding 15 plus 15, we see that there's a carry in every single case. But we need to add 6 again. To get this, we of course need to add another adder circuit, unfortunately. So let's zoom out. We need to take all of this. And do copy pasta. So with this third adder circuit, which adds 6 only one extra time, we will grab a 1 from here. So this 1 is the original 1, the 1 in binary, which always seems to work regardless. Then we'll add C, then B, then A. So we have our 4. And then we need to ground 2 states. So as we can see, if we look over here, we have the final XOR grounded. And one of the first XOR that we have here, and the second XOR we have here added to 6. So let's bring this around. This will be here. This will be here. And this will be here. Then need to short 1 to ground. Or in this case, we need to short 2 pins to ground, be it that the switch doesn't work very well if not done so. So we just need to short this one. And then these two will add 6 for us. If and only if there's 3 carries. Can there be 3 carries? Let's look. Well, what we have is the first time adding 6, then adding 6 again. Then we're left with 10. 10 can't be displayed, so it needs to add 6 again. So what we can say is, if this has 2 carries, so if it has C1 and C2 and if it has A1, C1, C2 and A, B. So if A and B are high, C2 is high, C1 is high. So basically, if there's 10 and 2 carries, then add 6 again. So let's go back. So we have our first adder, our second adder, our third adder, and our fourth and final adder. This final adder is for adding 6 once, and only once. If So let's, what we're looking for is if there's a carry, if we add 6 once, if we add 6 twice, and also if our value is AB. Unfortunate truth is that this needs to be brought down. Oh, smack the camera, fortunately. Let's save this. This gets deleted. And brought down. Like so. This is the ones. This is the... Let's delete this. Bring it around. This here. This. And do this. So we said only if the output of A and B is A and C. Oops. If A and C are high. So we take 1 from C and 1 output from A, and we add 6. Oh, oops. Wrong place. From here. Then we add 6. And then we output a carry. Just try it out. First, let's bring this all the way up here so we can see it as we're flipping. 24, 26, 28, 29. It is not adding 6. We have 15, but it's not adding 6. Let's see why. It's a high. That's a low. At 15, it doesn't... It doesn't add 6 at 15. That's because we need to connect to the carry, not to the output of 6. Still 14. Still 14. Why is it showing 14? I don't want it to show 14. I want it to show 0. Digital high, low, low. Okay. So it's not adding 6 because it doesn't see 10. It doesn't. Why doesn't it see 10? $14. Okay. So let's diagnose this. We've just determined that if we add 15, we get 7, which adds, we get 14 here with a carry, which adds 6. A carry stays, and we get 4 because there's a carry. After that, it adds 6 once more because of the second time, and then we get a value of 10, which can't be displayed. So let's actually go back and determine, do we actually get do we get 10 after we add 6? Again, instead seems that we get 4. Question is, why do we get 4? Probably because I had done my calculation wrong. So let's do 1 1 1 1 1 1 1 1. Add them together. 0 1 1 1 with a carry. We add 6 on top of this. 1 0 with another carry. Therefore, add 6 once more to get 10. Which, strangely enough, if we do not add 2 15s together, four. As we can see here, we do have a 4. So from that 4, is 4 over here? Yes. Therefore, my 10 should be here. No, I'm not getting it. So, I guess I was looking at the wrong place, but basically here is over here. So, I need to not look for 10, but rather for 4. First, we should turn this off and say I want it to go high when it's at 4. Okay, so let's try it now. All right, there you go. I have 10 at the output. 1. Yes, I have 10 entering here. I have one extra adder that I do not need. I have 10 here. It's converting my first to a number, then adding 6, then checking, then adding 6, It's my adder. My first is my adder. Okay. Okay, so I have my adder here. Then I have my second adder. So this adds 6, add 6, add 6. So do I have to add 6 again? Flip the wrong switch. I guess I have to add 6 again. It seems. I don't know. Wait, I feel the first adder, then the adder, then this adds 6, then add 6, then add 6 to get 10. But it's adding 6 twice. This tells it's to add 6 once. Then it takes this again and tells it add 6 again. And then this output should give me 10, but it gives me 4. So what is this output? Zero, 0, 5, 0. So there is 4. Therefore, add 6. Meaning this should be at 10. But it's at 4 again. Why is it at 4 again? Now that is confusing. It's at 4 twice. So I'm putting in my 15. Then it checks that it's both 15 because it sees 14 at the input, 5, 5, and 5 again. Therefore, it tells it to add 6, giving me 4. Because it carries again, and it tells it to add 6 once more. Oh, because it's not adding 6 at 15. That's why it carries down. It's not adding 6 the second time. Alright. I see. So what can be causing it to not add 6? We've said it's either or state. So we had determined that it will only go high. Where have we written? If C1, if there's a carry, if there is a carry at the start and evaluate A, evaluate C, evaluate A, and C or B. Or carry a 2 with a 0 on A and B. So we ended up getting 4. So at 4, which is not in the second criteria, which is here, 4 cannot exist here because that makes B high. So this gets eliminated completely, as seen here. There's a low because of this digital low, because there's a high and a low because of the whole inverter setup. Therefore, we'd have to move on to the other alternative, which is a carry, evaluate A, and evaluate C or B. So if we look for this, our carry is present, but our numbers are not. Reason is because, as we can see, it implies that it's either B or C and A, but A is not existent. A is not existent. If we take a look at 7, if we take a look at 7, not 7, sorry. If we take a look at 15 and we add them together, we had 14. Then we're at the state where it checks. We're at 4. 4 doesn't pass the first criteria, so we have to look at the second criteria, so we look at the first. And we say, okay, is there a carry? Yes, there is from before. Is there anything on A? No. But is there anything on C or B? Yes, there is one, which we can actually see over here. This OR gate indicates the C or B here. So basically we have this weird issue so that only in this state will it just bypass the first adder, because it basically goes around all these rules and just tells it it doesn't need to be added, so just move it to the next. So what we could do instead is, instead of it having another adder, so let's save this. So instead of putting another adder, what we do, let's eliminate these. We say, okay, well, if my output given to me, if my input rather is 15 and 15, then turn put everything to ground, and using this decoder here, make both of these high. So let's try that method. Let's bring this all the way up here. And we'll say, starting from the beginning, if everything is 15, so let's say for variables, say if all of them are high, basically A, B, C, D. We can't simplify this any further. Basically, it's 3 AND gates connected like so. So if all of them are high, then do two things. One, put everything at the first light to 0. So let's do this big line here. Let's make this one blue. So this is going to be the 30. So let's make it neater so I can bring it up easily. Oops. Nope, not there. If the outputs of the XORs equal to wait, no, actually this requires to check for both. So we need to do it like this. So this arrangement of AND gates consisting of 7 will tell the system when all of them are high. Basically, we're going to take this big node and we'll say, okay, this 15 state here, if we take a look at it, we can see that this 15 state, we will take an inverter and invert everything so that it just slams everything low. Like so. But at the same time, we'll take this all the way to our decoder and say put both of these high. Therefore, we can delete this one, this one. We will then again try this out like this. There. All right. So, in theory, and hopefully, this works out as planned. There is a problem. Okay, I know where that is. That is here. I need to put a resistor because I'm shorting everything to ground that way. And I don't like doing that. So let's put a resistor, 1K resistor right here. And let's try it. No, there's a problem. Okay, so this method doesn't work either. Ugh. Well, everything up until 29 seems to work just fine. In fact, I think I need another resistor. That might be the problem, because I'm shorting many things to ground. So I gotta do this. Try it here. No, there's a problem. Okay, so basically, I can't force it into a state that I want. Unless I take this and nope, this shorts them and I can't have that. What does this say? Node 105. might not be properly connected. Yeah. Okay. Well, it seems to me that this getting to 30 seems to be a problem, but from what I can tell, everything else seems to work fine as intended. So let us Okay, Kat, do you mind in chat typing how loud I sound if I need to increase my volume? Where's the problem now? Oh, yeah. Okay. Do you mind typing that in chat? Oh, it doesn't really matter. Alright. Well, so I'm going to stop this recording now. So basically, this is a, basically showing off the circuit and its construction. Next, I'll be probably tomorrow. So next time, basically the next recording after this, I'm going to implement it on a breadboard. Of that size, I'm not too sure, but I'm going to try it on a breadboard like this. In fact, I have a DSLR to be able to zoom in on said breadboard if there are questions about it. Like so. In any case, basically I'm gonna get everything set up so I can build it and hopefully I can get it to work.